All right, guys. We're going to keep going through the review sheet. So we stopped, or we did number 24. No, that's 29 last. And the biggest thing I would say with most of these here is if you see a way to solve it, it looks like the way to solve it, go on and do it that way. Now, we'll look at these two here. We'll look at both of them. So one of them we have sine of x over 2. The other one we have tangent of 2x. Now we do have half angle formulas and double angle formulas with this here. Because for sine of x over 2, well, we could say that it is the same as the square root plus or minus square root of 1 minus cosine theta over 2, but that's not going to be really helpful for this here because having it squared is helpful, whatnot. But if we look at this here also, is there any other trig functions with it? No, it's just sine of x over 2, yes? We can solve it. Because if I had cosine in there or another trig value, then I would be defaulting to the half angle formula or double angle formula, the other formulas. But here, well, I can just get sine by itself. We can subtract square root of 3 from both sides, telling us that 2 sine of x over 2 is equal to negative square root of 3. Then we're going to divide both sides by 2, telling us sine of x over 2 is equal to negative square root 3 over 2. Because there was only one sine, even though we had x over 2 inside for our angle, we can still solve it the exact same way we've been doing these here. At this point here, we can say that x over 2 will look on the unit circle at the y values to see where sine is negative square root 3 over 2, which would be 4 pi over 3, and 5 pi over 3. And that should be x over 2. Yeah, I'm going to rewrite that. Questions on this here? Okay. Now with the fact that we have x over 2, even though it does tell us we're on the interval of 0 to 2 pi, we'll still need to add the 2 pi in to solve because there can be multiple angles that work for this here, even though we are restricted from 0 to 2 pi. Yes.
If we don't put 2 pi in, like, if we don't really know, like, would it get counted off a lot?
Not a lot, because we'll see here in a second what's going to happen. I'll show both cases. Because here we don't have x by itself. So what I'm going to have to do is multiply both sides by 2, which will tell me that x is equal to, and this will answer your question here in a second, of leaving off the 2 pi in. Because our 4 pi over 3 times 2 is going to be 8 pi over 3 plus 4 pi in. We'll have to do the same thing over here. We're going to have to multiply both sides by 2. They cancel, telling us x is equal to 5 pi over, not 5, 10 pi over 3 plus 4 pi in. Questions on this so far, and we're going to get to your question here. Now, n can be any number we want. Normally we do 0, 1, 2, 3, 4, 5, 6, going up. But we can also have it be negatives in that case too. Because 8 pi over 3, 10 pi over 3 are actually a little too big. Because 8 pi over 3 is this here, or approximately 8.23. And we want it between 0 and 2 pi. Well, 2 pi is 6. So we've actually gone outside the range. We'll actually have to come back. So what we can say is 8 pi over 3 minus 4 pi. Really, we'd say plus 4 pi times negative 1, which is still outside our range. Because it's finding the coterminal angle for it. Okay. Because the coterminal angle for 8 pi over 3, we'd have to subtract 2 pi to get it. Remember. Yeah. Interval 0 to 2 pi, that's not 2 pi. I'm trying to remember what the answer I put down. You mind if I borrow? I'll get that out. 30. Yeah. I just left it as 8 pi over 3 and 10 pi over 3. Even way too big. Yeah. Because we'd have this here as our half angle would work. But that's it. Yeah. Really just, okay. There's, yeah, since this is too big, okay, let me explain. So here, 8 pi over 3, if we subtract it, 8 pi over 3 plus 4 pi times 0 does give us our 8 pi over 3. And if we do 1, it's going to be way too big. 20 pi over 3. So here we end up leaving it as 8 pi over 3 and 10 pi over 3 plus 2 pi in. But luckily, especially for the ones we'll have, we won't have to worry too much about it. I don't think there's too many like this, and if there is, I will take either this or just these two here. Okay? Because I'm wanting to subtract 2 pi to get it back to between 0 and 2 pi. But our 4 pi in really doubles that, so there's not any that are between 0 and 2 pi. So this has to actually be all real. But that's beside the point. If you can at least get me to 8 pi over 3 and 10 pi over 3, I'll take it. Okay? Let's look at the next one. Tangent of 2x plus the square root of 3. Now again, since we only have one trig function, we just need to get this thing equal, or get the tangent by itself. So we can subtract square root of 3 from both sides, telling us tangent of 2x is equal to negative square root of 3. Now, tangent of 2x is the square root of 3 at our pi over 3's. And tangent is negative in the second, so that'd be 2 pi over 3. And our fourth, which would be 5 pi over 3. I have a feeling, especially the answer key, we would divide both sides by 2 in both cases, telling us that x is equal to pi over 3, or x is equal to 5 pi over 6 are the two answers we get for it there. The pi over 6. So tangent we flip to the back. So on the grid that we have on the back, it does have tangent of our three angles. So pi over 6, pi over 3, and pi over 4. Now at pi over 3, tangent does have a value of square root 3. Yes? So all of the angles on the unit circle that have that number pi over 3 are going to have square root of 3. And the first quadrant tangent is positive. So at pi over 3, it's positive. In the second quadrant, at 2 pi over 3, tangent is, so it would be negative square root of 3. Yeah, 2 pi over 3. Yes. So we got 2x equals 2 pi over 3. So whatever the angle here is, when multiplied by 2, yes. And then the third quadrant, tangent's positive at 4 pi over 3. And in the fourth quadrant, it's negative again. We get our 5 pi over 3. And the answer key does have 2 pi over 6, but that reduces to pi over 3. And we'll leave it there. Questions on these here? Well, luckily enough, I'm not going to, because there are possible answers, I just want you to get these two.
Okay.
I'm not going to try to overcomplicate. I wouldn't worry about the 2 pi n, especially as any of them, because all of them are going to be between 0 and 360. Because the only ones that could possibly, so here we could possibly get alternate answers, because if we added the 2 pi n, we would have to divide it by 2 also, which would just give us pi n. And then we could do, well, pi over 3 plus pi times 0, which is pi over 3. Okay, that doesn't change anything. 1. So realistically, 4 pi over 3 would be one of our other answers, but 7 pi over 3 is outside. So 4 pi over 3, because there is technically another answer for both of them because it's double or half. So we have that there. But again, I just want you to mainly get to the first two. All right. Questions on 32 or 33? Either one of these that you all want to look at. I'd say they're really both about the same. Because the issue with both of these here is that we have sine and cosine. So, all right, guys, focus up here. Now, for 32, we really need this all in terms of cosine, because cosine is our trigonometric function without the exponent. So we can use our Pythagorean identity, that sine squared is equal to 1 minus cosine squared, and replace this sine with 1 minus cosine squared. Is equal to 4. Now at this point here, we can distribute through. 2 times 1 is 2. 2 times negative cosine squared is negative 2 cosine squared of x plus 5 cosine of x is equal to 4. Now, since we do have a squared term and a middle term, we do need to get this equal to 0. We do have it in a quadratic type form. So we can subtract 4 from both sides. Now our 2 minus 4 will give us negative 2. Questions on how we got to this point here? Now, luckily, all the ones on the test are going to be factorable. You're not going to have to use the quadratic formula for any of these here. But to help us be able to factor this a little bit easier, we can multiply by -1 or divide by -1 to get this first term positive. Because when factoring, having that first term positive isn't necessarily a necessary step, but it does make things easier. Because it's going to make our cosine squared be positive. It makes our 5 cosine of x negative and makes the 2 positive. And well, 0 times -1 is still just 0. Now at this point we can factor. Two sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factor the first term, well, we have cosine of x and cosine of x. Factors of 2 are, well, 1 and 2. So we just need to put 2 and 1 up front of one of them. Factors of 2. 1 and 2, yes? Where do you want to put the 2? Okay. And this actually ends up not being the correct factors. Right. All right, we can't put the 2 with the 2 cosine of x because then we would have a greatest common factor. And since the original quadratic did not have a greatest common factor, the 2's can't go together. Now we can check and make sure. This is the correct set of factors. 2 cosine of x times -2. -4 cosine of x. -1 times cosine of x is negative cosine of x, giving us -5 cosine of x. If we have 2 or more things multiplied together to equal 0, one of them has to be 0. So the first thing we can do here is add 1, telling us 2 cosine of x is equal to 1. Then we would divide by 2, telling us that cosine of x is equal to 1/2. Let's go and solve the other one. Add 2, telling us cosine of x is equal to 2. Now, since we just have cosine of x, this one for sure, we don't even need the 2 pi n to have anything to do with it there. So here, if we look at the unit circle, we're looking for where the x value is 1/2 for cosine, so 1/2 and 5 pi over 3 are the 2 values for it. And since we're restricted to 0 to 2 pi, all the ones that you solve on the test are going to be restricted from 0 to 2 pi. We get this here. We ready for the other one? Yes? Where on the unit circle is cosine of x equal to 2? Cosine of x equals 2. Huh? That one doesn't exist because the biggest value cosine can have is +1. The smallest it can have is -1. If it gets outside of 1 and -1, it doesn't exist. There is no value for that. So our only 2 solutions are pi over 3 and 5 pi over 3. Because if it was secant of x equals 2, then yes, we do have a value. Secant and cosecant can be greater than 1 and less than -1, but sine and cosine cannot. Questions on this here? Because the next one would be a very similar process, except instead of replacing sine for cosine, we'd replace cosine for our 1 minus sine squared. Yep. Yep. Just stick it right there. All right. Questions on 36 or 37? Okay. Sine of 7 pi over 6 minus pi over 3. So we're looking at a difference, the sine's difference formula, which would be sine of 7 pi over 6 times cosine of pi over 3 minus cosine of 7 pi over 6 times sine of, pi over 3. So we'd be using the difference formula, not distance formula, difference formula. And then we can reference the reference sheet and see that sine of 7 pi over 6 is negative square root 2. 7 pi over 6. Sorry, not square root 2. I'm looking at the wrong one. 7 pi over 6, so that would be negative 1/2. Cosine of pi over 3 would be, well, 1/2. Minus cosine of 7 pi over 6 is negative square root 3 over 2 times sine of pi over 3 is square root 3 over 2. Our 1/2 times negative 1/2 is negative 1/4 minus negative square root 3 over 2 times square root 3 over 2 is going to be negative square root, well, start at 9 over 4. Negative negative makes positive. We'd have 1/4 plus, well, 3/4, which gives us 2/4 or 1/2. Yeah. 7 pi over 6 minus pi over 3. Only thing you do have to make sure is that your calculator is in radians and not degrees, because it will give you a different answer. Because it is indeed 1/2, but if we have it in degrees instead of radians, it'll give us this answer. Questions on 36? Well, 36 through 42, all of those we can just type in the calculator. We just got to make sure that it's in the correct mode, because if they give us degrees, we need it in degrees. If they give us the angle in radians, our units with pi, we need it in radians. So really, we can type all those into the calculator. If it has pi, it's radians. If it's, I think for most of those, I did put a degree. If there's no pi, it's degrees. I think we feel good up to 42, yes? 43 through 46. One of these that we want to look at. There's really not any of them. 43. This here is really purely formula based. So we have So we want to write each expression as sine, cosine, or tangent, a single term. So we have sine times cosine minus cosine times sine. Well, that's our difference formula for sine, because sine of alpha minus beta is equal to sine of alpha cosine beta minus cosine alpha sine beta. And again, this is just coming from the reference sheet. Now, alpha in our case is 3, beta is 1.2. So really what we can say is this here is going to reduce to sine of 3 minus 1.2.
It's open. It never works.
Which is just telling us it's sine of 1.8. Okay. Questions on 43? Because 44, this here cosine, really we have alpha beta would be our cosine of alpha minus beta. Because cosine of alpha minus beta is cosine alpha, cosine beta plus sine alpha, sine beta, which is really telling us that this is our cosine of 60 minus 15. And 60 minus 15 would be cosine of 45. Thank you. And that's it for that one there. Questions on any of this here? Questions on 45 or 46? So we feel good with these here? Because for the most part with these here, we just match it up to the formula for our sum or difference, or the ones we have, and then plug in our angle and simplify. Because these here, we're not looking for a numerical answer. We're just trying to rewrite it as a single term. We ready for the next set? Yeah. Because we can, so this here is tangent of alpha. So we have tangent of pi over 15 plus tangent of 2 pi over 5. This is our sum formula. And when you're trying to match these up, I would be looking at through the theorems and seeing which one is similar. So much not with the values, but on top we had tangent plus tangent over 1 minus tangent times tangent. So for alpha plus beta, it has that same form. Now if instead of plus on top it was minus, instead of minus on bottom it was plus, then we would have difference. So we're looking for less about the angles, more what does the rest of it match up with. So here we'd have tangent of pi over 15 plus 2 pi over 5. So luckily we don't necessarily have to. Pi over 15 plus 2 pi over 5. How to add those together because the calculator will do it for us. That's it. Or not so much the full thing, but just the pi over 15 plus 2 pi over 5. So it will add those two fractions together to give us our single term. Because for these here, since we just want to write it in terms of sine, cosine, or tangent, you just want a single expression. We're not so much finding the value of tangent of 7 pi over 15. We just want to get this tangent 7 pi over 15. For this one here is again the difference. It's going to be cosine of 3x minus 2y for this here. Can we combine 3x and 2y? So that's it. So these here are less about solving and more, do you recognize the formula and know how to condense it. Does that make sense? I have a feeling the next ones. Okay, because there might be some that go the opposite way. We're given one and so much expand, but most of those we can plug in because it's wanting the value. So find the exact value for each expression with these here. Now the nice thing with these four here is we have a single setup that we're going to be using. Now for this here, I'm going to put it, yep. Right here in the middle, because we're going to set our triangles up. Now on the test, if you have space down at the bottom, I'd put it there. I'm just putting it somewhere out of the way so we can still work the four problems. Because up here, it told us angle U is between pi over 2 and pi. So our triangle setup is over here. This is angle U. And sine is opposite over the hypotenuse, so 24, 25. Now we can use Pythagorean theorem to solve for the third side, which would be our a squared plus 24 squared is equal to 25 squared. I am skipping steps, but we would subtract the 24 squared and then take the square root of it. Second square root, 25 squared minus 24 squared is 7. Now we do have the plus or minus, and since we are on the negative x-axis, it has to be negative 7. Normally when we talk about triangles, it would be positive, but because we're in the negative axis, it's negative 7. Now, any questions about angle U before we look at angle V? Yes.
Are the formulas that we're using for these, are they on the back of this?
So the one we just used is just the Pythagorean theorem. A squared plus b squared equals c squared.
I think, like, isn't it the sine?
Yes.
It's like the 2 point.
So this is on the reference page. So this is our sum and difference at the bottom. So 47's difference, 49's difference, 48 and 49 are sum. But the reason we're doing this with the triangles is so that we can get the value for U and V beyond what they were given to us. Because if we look at, say, 47.
Are they here?
Yes. Yep, so they're all on the reference sheet. Because for 47, our difference, this would be sine of U cosine of V minus cosine of U sine of V. Now, just from the problem itself, it told us sine of U is 24 over 25. And it did tell us cosine of V is negative 4/5. Now, cosine of U, we weren't given. Sine of V, we weren't given, because we were just given those straight from the instructions. Now, by setting the triangle up here in the center with U, cosine of U, cosine is adjacent over the hypotenuse. So cosine is negative 7 over 25. Now, sine of V, well, unfortunately, we don't know sine of V yet because we haven't finished the setup for that triangle. That's why we're doing that there. Now, we're told that cosine of V is negative 4/5, adjacent over the hypotenuse. And we actually know what the other side of this triangle is. It should be what? 3. And since we're in the negative y-axis, it will be negative 3. Because it's our 3, 4, 5 right triangle. Does that make sense? Yes, no? Huh? 5 would be positive. The hypotenuse is always going to be a positive distance. The -4 and -3 are negative because of our x-y axis. Also, since we're in the third quadrant, sine and cosine values are both negative. So we need that negative value. And with that there, so sine of v, opposite sides are -3, hypotenuse is 5, giving us our -3/5. Does that make sense so far? Because now that we have those, we can find sine, cosine of those angles, or tangent. And at this point here, you can type that whole thing into the calculator, let it do this calculation for you from here. Because otherwise, we're going to multiply these two together, -4 times 24, -6, -96. 25 times 5 is going to be 125. Minus -3 times -7 is going to be positive 21 over 125, which will tell us that this is -117 over 125. But that's it. Does that make sense? So the triangles is really just set up so we can find sine, cosine, tangent. We can find those values. Because tangent of u minus v would be our tangent of u minus tangent of v over 1 plus tangent of u. Well, sorry, I have them flipped. V, u, v, u here. Now, tangent of u. So if we look up at u, it's opposite over the adjacent. So for u, it would be negative 24 over 7. V would be opposite -3 over -4, which is just 3/4. Questions on how we got this set up? You feel comfortable at least getting it set up here? At this point, we can stick that entire thing as it is into the calculator. And it will reduce everything. It'll do all that. Should be 24. Yes, because 24 opposite over adjacent. And the calculator will do this here. I would just plug it in at this point, because it's not impossible to do by hand, but one of the first things we'd have to do is get the 7 and 4 to have like terms like bases, which is I think 28. What's minus 4 over 7 over 1 plus 3/4. It's actually going to reduce to -117 over 44. Questions on this here? All right. Questions on the other two with this here? We feel good with the other two with these here? Because at this point, it's just, because I think cosine of u plus v and tangent of u plus v, I would just come over here and say, well, it's going to be cosine of u, cosine of v, cosine of u minus sine of v sine of u. Cosine of v, negative 4/5. Cosine of u is negative 7/25. Sine of v, negative 3/5. Sine of u, 24/25. So we're just using the formula and the values for u and v with sine and cosine. And then again, just like we did with tangent, you can plug this whole thing in. This would be 28 minus 3, 2, carry the 1. Negative and negative make a positive. 25, 0. Over 125. 5 over 25. Should be 4/5. Nope. And that's it. All right. Well,